Hi, I am Junan. I will talk about the calculation for average mean, variance, and standard deviation of the case study. To calculate the mean is the sum of variable over the total size, so it is sum of x over n. And for the variance, it is sum of square variable over the total size minus square mean, so it is sum of x squared over n minus mean square. And for the standard deviation, it is the square root of the variance. So for the result, we let the S be the variable of the advertising expenditure, and to calculate the mean is sum of x over n. So we will get the 1x is 2 over 60 and get the 31 with the fraction of 1 over 30. Well, for the variance, we will get 61772 over 60 minus 31 with the fraction of 1 over 30 squared. So the answer is 66 and the fraction of 419 over 900. And for the standard deviation is equal to the square root of the variance, and we will get the 8.153. So for the result, we will get the average mean for the advertising expenditure in each month is $31033. This is quite high, and this must be because of the cost of maintenance, salary of workers, and the commodity cost. While the variance is $646, and the standard deviation is $8153. This means the spending in each month is spread over a bigger range from average spend.
Yes, and this is for the finding the probability value of case study. And so here is the methodology. I use a percentage probability test. So this refers to the likelihood of a certain event or outcome occurring, expressed as a percentage, where x over n times 100%, where x is number proportion of the particular outcome, and n is the total number of outcomes. And and here is the result. So I created two conditions. One is $30,000 of uh, advertisement expenditure, and another one is $45,000 of advertising expenditure. And from the table, there is around three, uh, which is 30,000 expenditure for advertisement over 60. So times that by 100%, we get 5% chance. And the second one, we get 1.67% chance. And so this is how uh, probability a percentage probability can kind of estimate an overall chance that a singular expenditure in a given month have a chance of occurring. And this is for a normal distribution case. And by the side, on the left side is the normal distribution table, and on the right side is the expenditure for the advertisement from ascending order, from reading from column and from left to the right. And here is the methodology. Normal distribution can be expressed as the following, and the standard deviation, somewhat normal standard normal distribution, where you can find the z-score is x minus mu over standard deviation, and from the z-score you can find the probability. And here also given two situations. One is greater than $25,000 of expenditure, and another one is greater than $40,000 dollar in expenditure. So first we have to find the mean, which is 31.03. Then we can find the standard deviation, which is 8.15. And so you can find the z-score for the first case, and then from the z-score we can find the probability on using the table, which is 0.7704 as approximate. And then the second one is when the expenditure is greater than 40,000. Then finding the z-score from the given mu and the standard deviation. Then we can from the table we can find that the probability of happening is 0.1357, and the to the right side is a normal distribution for the set of data.
Now I will present about the calculation of probability that average advertising expenditure is greater than $32,000 by separate distribution. In this calculation, we will use the central limit theorem (CLT) to solve, and the CLT says that when the sample size n is greater or equal to 30, the sample size can apply CLT for and using the normal distribution to solve. After applying the CLT, the average mean of sample will equal to the average mean of population, and the standard deviation of sample will equal to the standard deviation of population over square root of the sample size. And for the number distribution, the Z-score table is already presented by Ivan just now, and to calculate the Z-score is use the S variable minus average mean of sample over standard deviation of the sample. So for the result, we assume that the set of data with n equal to 60 as a population. The population mean will equal to the 31 with the fraction 1 over 30, and the population deviation will equal to 8.153. The sample taken from the population has the sample size of n equal to 30, and the CLT is applied. So that the sample mean will equal to the population mean. So is 31 with a fraction of 1 over 30, and the sample standard deviation will equal to the 8.153, the population standard deviation over square root 30. So is 1.489. So to find the probability that the average advertising expenditure of the marketer is greater than $32000, we find the probability of the Z score greater than 32 minus 31 with the fraction 1 over 30 over 1.489. So is the probability that the Z score is greater than 0.65, and the answer is 0.2578. So from the result, we know the sample standard deviation is equal to 1.849, and this means that the advertising expenditure selected in the sample has the value that only spread out the average mean 31 with the fraction of 1 over 30 in the smaller range. And the probability that average advertising expenditure is greater than $32000 is 0.2578. This means that part of the advertising expenditure in the sample chosen has a value that is greater than $32000.
Hi, I am Liu Zhenjie, and now I will talk about how to determine the beneficial connection between two relationships by using estimation. A confidence interval is a set of numbers between two values that likely to contain the parameter estimated. The confidence interval of an interval estimated of a parameter is the probability that the interval estimated will contain the estimated parameter. The sample size must at least 30, and the formula for confidence interval for my case study is Z alpha over 2 S over square root n. For the calculation, both sample size of advertising expenditure X and sales performance Y used is 60. Mean and standard deviation of X calculated is 31.1 and 8.9. Mean and standard deviation of Y calculated is 38.45 and 7.7. Confidence interval of 95% is used. For the result, the range found on advertising expenditure is between $28,850 and $33,540. The range found on sales performance is between $36,510 and $40,390. The advertising expenditure range of $28,850 to $33,540 correspond with a sales performance range of $36,540 to $40,390, suggesting that the investment in advertising aligns with increased sales.
Hi, my name is Muhammad Iqmal. Now I want to talk about calculation of hypothesis testing. This is the result. I'm using KC to solve this solution. So I just put the number is 31 1 over 30 minus 30 divided by 8.153 divided by square root of 60, and then I get 31 over 30 divided by 1.05, and the answer is 0.9841. And then we can see the Z test value is 0.9841, which is less than ZC is 1.6449. The decision is do not reject the null hypothesis. Thank you.
Okay, next I will explain about chapter 6. Okay, first the objective is to establish relationship between advertising expenditure and cell performance that make it possible to predict by using simple linear regression. Okay, next is the methodology. And this is a scatter plot advertising expenditure versus sale performance that was made by Excel. As you can see, plot, the graph is plot, and the simple linear regression is shown. And the equation is y equal to 0.6546 x plus 19.3522, and the uh, equation will be proven by the calculation. Okay, next is calculation and result. Okay, the calculation is we find the sum of x, sum of y, xy, xx, yy, and we know the sample is n equal to 60. Okay, and we find sxy equal to 2610.67, and sxx is 3987.93, and b1 is 0.6546, b0 is 19.3522, and equation the least square equation is y equal to 0.6546 x plus 19.3522. Okay, in this equation, we know that when the advertising expenditure increases by 1, the sales performance will also increase by 0.6546. Okay, that's all from me. Lastly is the conclusion. Okay, the mean represent the typical value in a data set, while variance and standard deviation measure data spread. Low standard deviation means data is close to the mean. High deviation implies greater spread. Central limit theorem allows using normal distribution for sample means, aiding statistical analysis. Z-score standardized data enabling comparison across population. Choose significant level carefully in hypothesis testing. Be aware of type 1 and type 2 errors. Correlation does not imply causation. Regression assumption must be met for valid result. Keep interpretation contextual and acknowledge study limitation. That's all.